Determine the exact values for each of the following. For part A, we want to find the exact value of sine of 11 pi on 4. So 11 pi on 4 has actually gone around the unit circle more than one revolution. So we can write this as sine of 12 pi on 4, which is 3 pi, minus pi on 4. So that means that we have sine of 3 pi minus pi on 4. So that's starting to tell us what quadrant we're in and what the reference angle is. So 3 pi is equivalent to going once around, that's 2 pi, and then 3 pi takes you to this position, and then we go back pi on 4, which means that our position on the unit circle is here. Then we know that we read sine of the y-axis, so we go across and we know it's going to be positive, and that's because we're in the second quadrant of the unit circle. Therefore, sine is positive. And if we have a positive sine value and the reference angle is pi on 4, we know that the exact value for that is going to be positive root 2 divided by 2. So that is the exact value of sine of 11 pi on 4. For part B, we're going to find the exact value of cos of negative 17 pi on 6. So if we inspect that angle, that's very close to negative 3 pi. So we could write this as cos of negative 3 pi. And just for a bit of explanation, negative 3 pi could be written as negative 18 pi on 6. That's why we chose it, because it's close to negative 17 pi on 6. And if we're at negative 3 pi, we need to add pi on 6 so that we end up as being negative 17 pi on 6. So what does that mean for our unit circle position? It means instead of going anti-clockwise, we're now going to go clockwise. So that's 1 pi, 2 pi, 3 pi. So that's negative 3 pi takes us to this position. And then we come back pi on 6 radians. So that means our position on the unit circle is somewhere around here. Now, as we're reading cosine off the x-axis, that means it's going to be negative. So in the third quadrant, which is where we're at, we know that cos is going to be negative. So now that we know our position in the unit circle, we're in the third quadrant, cosine's negative, and we have our reference angle, which is pi on 6. We know that this exact value must be, so the reference angle of pi on 6 is going to be root 3 on 2, and then due to the quadrant that we're in, we're going to have an exact value of negative root 3 on 2. So that's the exact value there for cosine of negative 17 pi on 6. For part C, we're going to find the exact value of tan of negative 25 pi on 4. So negative 25 pi on 4 is very close to negative 24 pi on 4. So we could write this as tan of negative 24 pi on 4 and then subtract another pi on 4. And what that's allowed us to do is work out how far around the unit circle we've gone in terms of pi. So minus 24 pi on 4 is minus 6 pi. And then we have minus pi on 4. So for our unit circle, that means we've gone backwards 3 revolutions. So that's 2 pi, 4 pi, and 6 pi backwards. So that's the negative 6 pi. And then we've gone another pi on 4 in the negative direction. So that puts our position somewhere around here on the unit circle. So with that in mind, we know that this is just equal to tan of negative pi on 4, which puts us in the fourth quadrant of the unit circle. Therefore, the value of tan is going to be negative. And all that's left to do now is recall that the exact value for tan of pi on 4 is 1. And as we're in the quadrant where tan is negative, the exact value is negative 1. So the exact value for tan of minus 25 pi on 4 is negative 1. For part D, we're going to find the exact value of tan of 31 pi on 3. So if we inspect that angle, we could write it as tan of 30 pi on 3 plus pi on 3. So that helps to identify what our reference angle is. It's going to be pi on 3. And if we have 30 pi on 3, that's just 10 pi plus pi on 3. And now going around the unit circle 10 pi radian, is going to take us back to 0 radians. So every time we go around 2 pi, we get back to here. And then what we're going to do is we're going to go pi on 3 around. So that will take us to here. So that's pi on 3 further than that position. So this is the position on the unit circle that we're interested in. And that means that we are in the first quadrant. Therefore, our value of tan is going to be positive because all trig functions are positive in the first quadrant. So all that's left to do, now that we have the quadrant we're in and the reference angle of pi on 3, is recall that the exact value for tan of pi on 3 is root 3. So the exact value of tan of 31 pi on 3 is also root 3.